derivation of this equation. Now I am going to solve this equation by using variable separable method or separation of variable method. Okay. So if you derive the equation, we will get the equation as ut is equal to c square uxx. Okay. So what do you mean by ut here? What I said? If you are representing a letter with suffix, what do you mean by that? That is dou u by dou t is equal to c square dou square u by dou x square. Xx means second derivative of x will get. Okay. So for this we need to find the solution using method of separation of variables. So in the method itself it is there. We need to separate the variables. Okay. So how will you separate the variables means based on the assumption that if u is a solution and its solution will be of the form x into t. Okay. Where x is nothing but function of x, that means x of variable x. Similarly, t is nothing but function of t, function of variable t. Okay, is the solution of above equation. Okay, so take this as equation 1. Okay, if you assume this solution will be of the form like this, substitute this into this. Okay, so from equation 1, I'll substitute u value here. What happens? Dou by dou t of u value is xt, where x is a function of x and t is a function of t, is equal to c square dou square xt divided by dou x square. Okay, since we are differentiating t with respect to t on the left hand side, x function will be constant. You can keep x outside. Dou by dou t of t function will get is equal to c square. Here you are differentiating with respect to x. So t function will be constant. So t will keep outside. Dou square x divided by dou x square, where x is a function of x. Okay. So now what I will do is I will separate the variables. All t variables at one side, all the other variables as other side. So here I will bring 1 by c square t at one side, dou t by dou t is equal to this x I am sending on the right hand side. You will get 1 by x dou square x by dou x square. Okay. So now let us assume that this value equal to some constant, okay, k. Okay, where k is a constant. Okay, where k is a constant. One minute. Where k is a constant. Okay, now based on this constant, we will decide the solution. Okay, so what I will do is I will equate this function to k and this function also equal to k, and I will integrate it separately, or I will solve it separately. Finally, I will club these equations. Okay, so let us see how to solve this. So 1 by c square t into dou t by dou t is equal to k I have taken. Similarly, 1 by x dou square x by dou x square is equal to k. Okay. So now I'll send these variables to that side. What happens? Dou t by dou t is equal to k into c square t. Similarly here, dou square x by dou x square is equal to k x. Now I will send this term to left hand side. That means dou t by dou t is minus c square tk is equal to 0. Here also dou square x by dou x square minus kx equal to 0. Okay. So now I will denote this one with respect to d. Okay. So d minus c square k into t is equal to 0, where d is nothing but dou by dou t, derivative with respect to t. Similarly, I'll write this as d square minus k into x is equal to 0. Okay. So where here also d is nothing but dou by dou x, or you can write it as dou square, d square is nothing but dou square x by dou x square. Okay. So now based on k value we'll check it. Okay. Take this equation as equation 2. Now from equation 2, so from equation 2 what we can say is, or otherwise you keep aside, let k have 3 chances. K might be equal to 0, or k might be a positive number, or k might be a negative number. Okay, based on these 3 cases, we'll find the 3 different solutions. Okay, so let us take one condition at a time. Okay, take k equal to 0. So based on k equal to 0, from equation 2, if I take k equal to 0, what happens? So first I'll write what is equation 2. D minus c square k into t is equal to 0. Here also d square minus k into x equal to 0. Substitute k equal to 0 here. dt is equal to 0. Here d square x equal to 0. Okay. So if you write the auxiliary equation for this, what is it? M equal to 0. Here m square equal to 0. Okay. So if m equal to 0 is a solution, how to write the solution? T is equal to c1 e power 0 t you will get. Here also, when solution is repeated, how to write? X c1 plus c2x into e power 0x. Okay, so therefore t is equal to c1. Here instead of c1 c2 we'll get c2 c3. Already C1 I have used. So x is equal to C1 plus C2x. Therefore, the required solution is what is it? U is equal to xt you have taken initially. Okay, so multiply these two solutions. You'll get the required solution. U is equal to C2 plus C3x. Wait a minute. C2 plus C3x into C1. Okay, so this is the solution which is required. So I can write it as equation 3. Next, take the condition K is positive. Okay, if you take K is positive, how to write the solution? Let us see. From that means, how do you represent what is K is positive means? We need to replace K is equal to if I take any positive number or any integer p, that means p is some integer. If you take square of it, this number is always positive, right? Okay, so I have taken p as some integer such that p square must be positive always. Okay, now I am replacing k with p square in the given equation, or from equation 2. Okay, from equation 2, what I'll do is, first I'll write what is equation 2, b minus c square k into t is equal to 0. Okay, next d square minus k into x equal to 0. Okay, so now replace k with p square. So that means d square minus c square p square into t is equal to 0. Sorry, here d not only there, d square it is not. Okay, so here d square minus p square into x equal to 0. Is my voice is audible?
Yes, sir.
Yes, sir. So now I'll write auxiliary equation for this. So how much you'll get? M is equal to c square p square. Okay. Similarly here m square minus p square equal to 0 implies m square equal to p square implies m is equal to plus or minus p. Okay. So we'll get this much. So therefore, what will be the solution if m equal to some constant? So this is nothing but t is equal to c1 e power c square p square. Similarly, here x is equal to c1 e power px plus c2 e power minus px. Okay, so therefore, the required solution is how much? U is equal to xt. So U is equal to x. X is here instead of C1, C2, C2, C3. So C2 e power px plus C3 e power minus px into C1 e power c square p square. Okay. So this is the required solution when k is positive. Now we have one more condition, that is k is negative. So we'll find that when k is negative, when k is negative, how to replace k value? If you want to represent k is negative means, here I said k is positive means some p square I have taken, where p is some integer, that p might be negative or positive. In the same way, I can take negative of p square. This will be always negative, right? Some number square, it is always positive and you are taking negative of it. So this will be always negative. So therefore, from equation 2, so what I'll do is, I'll take d square minus c square k into, sorry, d minus c square k into t is equal to 0. Into t is equal to 0. This is equation 2. Similarly, d square minus k into x is equal to 0. Now replace k with minus p square. D minus, here already one more minus is there, so plus c square p square into t is equal to 0. Here also d square plus p square into x is equal to 0. So what will be the auxiliary equation for this? M plus c square p square equal to 0. Here also m square plus p square equal to 0. So m is equal to minus c square p square. Here also m is equal to m square is equal to minus p square. M is equal to plus or minus pi. Okay, that means a complex number you'll get. So the solution for t is nothing but c1 e power minus c square p square into t. Okay, here also we'll get x is equal to, how to write complex solution for this? When your roots are complex, when my roots for m are complex, how to write the solution?
C1 cos pi plus C2 sin pi
C1 cos
into
Cx. So here C2 we have to write. C1 already
C2 and
is C3 sin Px. Okay, so this is the solution. So therefore, the required solution is, so the required solution is, what is it? U is equal to xt. Okay, so that is nothing but U is equal to x, c2 cos px plus c3 sin px into c1 e power minus c square p square. Okay, so in this way we will get all the three solutions. So now based on the given condition, we will decide whether we have to use trigonometric solution or this is exponential solution and this is algebraic solution. Okay, so equation 3 is called algebraic solution, this is exponential solution, and this is trigonometric solution. So this is equation 5. Okay, so just go through the solution once again from starting onwards. If you get any doubts, let me know. So let us see how to solve this. Okay, so here they have given the equation as utt is equal to c square uxx. So what do you mean by utt? This is nothing but second derivative of u with respect to t. So dt square is equal to c square dou square u by dou x square. So we need to find the solution and take this as equation 1. Now how will you solve using method of separation of variables? First we'll write the given, let u is equal to xt, where x is a function of x, that means function of x, t is a function of t, comma b the solution of equation 1. Okay, so from equation 1, if we substitute u value in this equation 1, dou square xt divided by dou t square is equal to c square dou square xt divided by dou x square. Okay, so here we are differentiating with respect to t, take x constant. So that means x into dou square t by dou t square is equal to c square t dou square x by dou x square. So same way how we had it in the previous class, sorry, previous topic or previous problem. So here I have taken 1 by c square t outside, dou square t by dou t is equal to 1 by x dou square x by dou x square I have taken. Okay, so for our convenience I will take this as equal to some constant k, where k is constant. Okay, so for our convenience what we'll do, we'll equate left hand side of this equation to k, that means 1 by c square t dou square t by dou t square is equal to k. Similarly 1 by x dou square x by dou x square equal to k. Okay, so now what we'll do is we'll simplify this. dou square t by dou t square is equal to c square t k. Similarly, dou square x by dou x square is equal to kx. So now I'll send it to left hand side. Dou square t by dou t square minus c square tk is equal to 0. Similarly, dou square x by dou x square minus kx is equal to 0. Now I'll write it in notation form. That means d square minus c square tk is equal to 0. Similarly, d square minus k, sorry, here 1 minute. C square k into t. Here d square minus k into x is equal to 0. Where here d square nothing but dou square by dou t square. Here nothing but d square is equal to dou square by dou x square. Okay. Now based on k value, we will decide the solution. So taking the conditions, where k equal to 0 or k is greater than 0 or k is less than 0. Okay. So first we'll take k equal to 0. What happens? So I'll take this equation as equation 2. So from equation 2, what we'll get is d square minus c square k into t is equal to 0. D square minus k square into t is equal to 0. Okay, if you substitute k equal to 0, d square t is equal to 0. Here also d square, sorry, here x will get. D square x equal to 0. So that means what will be auxiliary equation for this? M square equal to 0. Here also m square equal to 0. Okay. So 0 is repeated for twice. If 0 is repeated for twice, this is nothing but t is equal to c1 plus c2 t e power 0t. Similarly, x is equal to c2 plus c4x into e power 0x. So finally, t is nothing but c1 plus c2t, x is nothing but c3 plus c4x. So the required solution is u is equal to xt. Okay, so that means u is equal to what is x? C3 plus C4x into C1 plus C2t. Okay, so this is one solution. Take it as equation 3. So now what I'll do is I'll take one more condition, that is k is positive. Okay, if k is positive, replace k equal to some number square. Okay, where you can take p belongs to real numbers. Now from equation 2, here d square minus c square k into t is equal to 0. Next, d square minus k into x equal to 0. So this is the equation 2. In this equation, we'll substitute p square. So d square minus c square p square into t equal to 0. D square minus p square into x equal to 0. So that means m square is equal to, m square minus c square p square is equal to 0. Here also m square minus p square equal to 0. Here m is equal to c square p square. Here m is equal to m square equal to p square. Okay, so what will be m value then? M is equal to c square p square, plus or minus cp. This is also m is equal to plus or minus p. So we have two distinct solutions. When you have two distinct solutions, what will be the solution for t? Is equal to c1 e power cpt plus c2 e power cpt with minus. Similarly, x is equal to c1 e power px plus c2 e power minus px. Fine. So therefore, the required solution is how much? U is equal to xt. So that is nothing but u is equal to, here instead of c1 c2 we'll get c3 c4. Okay, so we get c1 e power cpt plus c2 e power minus cpt into into c3 e power px plus c4 e power minus px. Okay. So next condition is we need to take k is negative. So when k is negative, what and all happens? Let us see. Replace k is equal to minus p square here. So therefore from equation 2, what happens? D square minus c square k into t is equal to 0. Next, d square minus k into x is equal to 0. So that means replace k with minus p square. So I'll get d square plus c square p square into t equal to 0. D square minus, so minus of minus plus p square into x equal to 0. Okay, so that means here m square plus c square p square equal to 0 implies m square is equal to minus c square p square, implies m is equal to plus or minus cp. Here also m square plus p square equal to 0 implies m square equal to minus p square. M is equal to plus or minus pi. So here also cp I will get. Both are complex solutions. So therefore x is equal to, t is equal to c1 cos cpt plus c2 sin cpt. So this is one solution. Next, x is equal to c1 cos px plus c2 sin px. Therefore, the required solution is how much? U is equal to xt, which is nothing but u is equal to c1 cos cpt plus c2 sin cpt into c. This is not c1, c2, so these three, and this is 4. So c3 cos px plus c4 sin px. So this is the actual solution when k is positive, k is negative, and k equal to 0. Okay, here also we'll get trigonometric solution, exponential solution. Take this as equation 4, and take this as equation 5. This as equation 5. Fine. Just go through the solution once again from starting onwards. If you get any doubts, let me know.